Welcome to another miraX video tutorial. In this session, we will explore the subsidence tool. This tool allows users to simulate ground sinking due to compaction, settlement, and oxidation in peatland areas under different surface water scenarios. It can also be used to report the CO2 emissions avoided as a result of these processes. Let's take a closer look. The subsidence model requires information about the subsurface at a reference year, 2018 in this case. In this project, that information is provided in the form of a vector layer called boreholes. Go to the detailed information to get a detailed view of this layer. As you can see, each borehole contains multiple attributes. These include the X and Y coordinates in a local coordinate reference system, the average lowest groundwater level or GLG, and the vertical distribution of peat layers at each borehole location. These layers are shown from top to bottom, with V1 being the topmost layer, V2 the second peat layer, and so on. In addition, the model also requires the elevation of the terrain at the reference year. This layer is necessary so that future elevations can be compared with the reference situation. Now, let's run the subsidence tool. Go to the right toolbar and click the subsidence tool icon. A dialog window will appear with the model parameters, including the layer drop-down, in which the elevation layer must be selected. The year, that defines the target year for the simulation. The yearly loss value, which represents the proportion of peat lost per year due to degradation processes. The surface water increment, corresponding to the uniform increase in water level across the area. And the recharge factor, the percentage of the surface water increment that contributes to raising the groundwater table. Let's first run the baseline scenario for the reference year 2018, which represents the initial state of the simulation. Insert 2018 as the simulation year and click on Get Subsidence. The model will run in the background and generate several layers. Additionally, a small pop-up will appear in the center of the map, showing the total avoided emissions for the selected year. The list of output layers can be found in the User Layers section on the Side-by menu. The layers include the CO2 emissions avoided, the new elevation, the remaining peat thickness, the groundwater depth relative to the surface, and the subsidence values. You can toggle these layers on and off by checking the respective checkboxes. Now, let's create a simulated scenario. Open the subsidence tool again, set the simulation year to 2050, increase the surface water level by 0.2 meters, and leave all other parameters unchanged. Then click Get Subsidence. The model will run again and generate new layers for the year 2050. Just like before, these layers represent subsidence, groundwater surface, peat thickness, elevation, and CO2 emissions.